Okay, so hello everyone. I am Abhinav Kumar Singh from. I'm a third year student in BIT college, and I'm currently doing my bachelor's in CS. And today I'll be teaching you all about multiplexers. So let's take an example of what is a multiplexer. Now you might have seen let's take an example of a what I can say. Let's take an example of a petrol pump. Okay, so in a petrol pump we have various fuel reservoirs, right? And there is only one way from which the fuel comes out. So let's take the fuel reservoirs as example of an input and the fuel output as a real output. So that is what a multiplexer is. Like based on the selection line, based on which switch is pressed on which pump, the fuel will come out from that. Okay, so yeah, so based on what switch we trigger, the input will be selected from whichever storage tank we like. So that is what a multiplexer is. To define what is a multiplexer is a combinational circuit which has 2 to the power n input lines and a single output line. Simply, the multiplexer is a multi-input and single output combinational circuit. The binary information is received from the input line and directed to the output line. On the basis of the values of the selection line, one of these data inputs will be connected to the output. So basically what we have to do, like in a multiplexer we have to do the power and inputs, and we have n numbers of selection lines. Based on the selection line what we have, we will select the given input and produce the output. So coming forward, we have what is a 2 is to 1 multiplexer. Okay, so this is a block diagram of a 2 is to 1 multiplexer. So let me define what is a 2 to 1 multiplexer for you. So it is nothing but it has two inputs and only one output. Based on the select input, the output Y will be produced. This is how it is. If S is 0, the output Y will take A0. If S is 1, the output Y will take A1. So let's see the figure. Now see, if S is equal to 0, then this A1 will be nullified, right? And if S is equal to 0, this 1 will go, this AND gate will produce A0 as the input and will get A0. Now if S is 1, this AND gate will get nullified and this one will produce the output. So that is about 2 is to 1 multiplexer. Now coming forward to what is a 4 is to 1 multiplexer. This is a diagram of 4 is to 1 multiplexer. So 4 is to 1 multiplexer has 4 inputs, one single output and two select lines. Based on the select line values, we'll select one of the following given output. So you can see the truth table. If the input is 0 0, we have A0 as the output. If the input is 0 1, we have A1 as the output. If the input is 1 0, we have A2 as the output. And if the input is 1 1, we have A3 as the output. You can keep the value in this circuit and figure it out how the value of y is given. Let's take an example. Let's take 1 1. So when both are 1, this will go straight to this AND gate and A3 will produce output and rest all will be nullified because it has at least 1 0 as an input. Okay, let's come on to what is a 8 cross 1 multiplexer. Okay, so similar to the previous ones which we saw, 8 is to 8 is to 1 multiplexer is okay, so 8 is to 1 multiplexer is nothing but it will have 8 inputs and one output based on the select lines. Like if the select line is 0 0 0, we'll have A0 of the input. Similarly, it will follow for A1, A2, A3, A4, A5, A6, A7. Now let's take an example. Let's take 1 1 1. Okay, so if we have 1 1 1, we have to select A7 basically, right? So let's take okay, so S2 is also uh, 1 1 and 1. Okay, so if it is 1 1 1, we have to select A7. Now see, if it is 1 1 1, we'll have this 1 1 and 1, and S7 will be selected as the output. That is how it works. There is a minor change in this diagram. Instead of from 0 to 7, it will be the instead of A7 it will be A0, and the last will be A7, and vice versa. So change it accordingly. Now let's come on to the code. So this is a VHDL code uh, for 2 is to 1 multiplexer. Now before I explain you the code, I'll tell you what, in very simple terms, what is VHDL. So VHDL is okay. So VHDL stands for VHSIC, Hardware Description Language. It is a programming language used to describe the behavior and structure of a digital system at multiple levels for abstraction from the system level to the gate level. Basically, it is a hardware description language which helps us to design various gates, various circuits, and it also helps us for verification and synthesis. So this is a VHDL code for 2 is to 1 multiplexer, which we saw here. This is a 2 is to 1 multiplexer. This is a VHDL code for it. The first thing which we are doing here is uh, taking the importing the libraries, which is IEEE .std logic, which will help us to take standard inputs like steady logic and steady logic vector. So here we have A and B as the input and steady logic, and cell as the input, and Y as the output. Now if uh, cell is equal to 0, A will be selected, and elsewise B will be selected. This is how this code is working. And to conclude, what we see here is it is a VHDL code which effectively simulates the behavioral model of a 2 is to 1 multiplexer. Now coming forward to what is the VHDL code for a 4 is to 1 multiplexer, the same thing which the same thing only we are doing here. That is, we are importing libraries. Then from that libraries we are using the std logic underscore 1164 all, which will help us to use this std logic and std logic vector. Now cell here, what is the use of vector? So that vector is helping us to take a 2-bit selection signal. So basically cell we need to take 4 values, right? Like this 4 values I take from the truth table, you can see. So this std logic underscore vector will help us to take all those 4 values. So we'll declare the port and all, and then we'll start. Now when the cell value is 0 0, it will take A. When it is 0 1, it will take B. When it is 1 0, it will take C. When it is 1 1, it will take D. And on all the other cases, the value of Y is set to default, which is 0. We end the case, we end the process, and we end the behavioral architecture. Now coming forward to what is the 8 is to 1 multiplexer. In the 8 is to 1 multiplexer, the same stuff we are doing again. Importing the IEEE library, importing the IEEE.std logic underscore 1164, which will help in nothing but to use this std logic vectors and the cell. Now the cell here has a 3-bit selection input, and the D will have 7 to 0, basically 8-bit input vector, in which each bit represent one input data. So when cell value 0 0 0, it will select D0. Similarly, we'll go till D7, and yeah, pretty much that's it. We end the case, we end the process, and we end the behavioral model. So this was all about the multiplexers. Now there is one more additional multiplexer which we are not discussing in this video. That is 16 is to 1 multiplexer. It is a bit complex. I can try to explain you that. Maybe by taking an example. Just a second. Okay. So this is what a 16 is to 1 multiplexer looks like. it has 16 inputs, 4-bit selection lines, and one output, which is Y. This is the truth table for it. This is how the truth table looks like. We have 16 inputs and we have output Y, which will select like any one of the 16 inputs based on the selection lines. Now for this we have a circuit diagram also. This is a circuit diagram for a 16:1 multiplexer. We'll not be discussing the code for it, but this is pretty much what is 16:1 multiplexer is. This is how the circuit diagram looks like, this is how the truth table looks like, and this is how the block diagram looks like. So that is all for this video, and I hope you all liked the video, and I hope you all understood what did I explain in the video. Thank you for watching, and looking forward to a great response. Thank you.